to improve the security of the browser that would be included in Longhorn. And Jim made some references to IE and more generally to some of the Longhorn security features in his discussion a few minutes ago. I asked Rob to try to give you an introduction to the architecture of IE, which I think we didn't do. We sort of plunged into the middle back in March. So I asked Rob to come back and give you more of an introduction that starts out with the architecture and the things that we're looking at from an architecture perspective to try to mitigate or eliminate vulnerabilities from IE at an architecture as well as a mitigation level. And I think he's done that in a presentation that I hope you'll find interesting. As always, try for the 20-minute rule unless he waives it, and you say he shouldn't waive it. No waivers. All right. So this Rob Franco, you've seen him before. I think this will be a very interesting presentation for you. Rob, you're as close as they get to hearing about Longhorn.
That's right. Well, thank you, Steve. Thanks for having me back. I'm actually really excited to come back and talk about the architecture from a deeper level. Lots of good feedback in our last exchange. And I want to go over some of the rules of engagement that we use as the IE team, the rules of the game. I want to go over the architecture, as Steve pointed out, and actually do some kind of live threat modeling. That's a part of our process, that the security development lifecycle, that we actually threat model in order to decide where we're going to make our security investments. After we do that, I will actually walk through how we'll mitigate the threats that we identify. And then we'll actually see some demonstrations of those mitigations as they've been coded and some visuals of some of the mitigations that I'm not able to demo today. So, to give you guys an idea of what it's like to be engineering or re-engineering, sometimes we call it, Internet Explorer, our job is to provide a secure browser that's still functional. So, the Lynx browser that, of course, Outlook decides it wants attention. The Lynx browser, where I'm just looking at HTML, where I'm looking at raw text, no images, nothing else. Clearly, that's not functional enough for the internet as we know it today. And then the all dancing, all partying, all the time, developers gone wild browser, where code just gets installed on your machine, isn't something that we can obviously have either, because that gets us into some of the security problems that we have to deal with. So when I look at the tools at my disposal that I have to address these issues, I've got three. And the most powerful of which is re-architecting the product to eliminate vulnerabilities. And that's specifically when we met last time, I didn't do a good job of calling out the differences between architectural changes and mitigations. Mitigations are my second tool in my bag. Mitigations reduce the severity of a vulnerability. So an example might be the local machine zone lockdown in Windows in IE for XPSP2 reduces the severity of a cross-domain vulnerability from a critical vulnerability down to an important. So that's a mitigation, not an architectural removal of cross-domain vulnerabilities. We'll talk about those types of vulnerabilities more later on. And then, obviously, when we ship a security update every time, we go and target an issue and all of its known variations of it. So you could imagine that, let's say there's an ActiveX control that has a problem when it's loaded in the browser, that it can cause a crash, or maybe I can use it to elevate privilege on the user system. Well, that ActiveX control will be very targeted, and we'll go after that ActiveX control and just kill that in a security update. You guys don't want to hear about security updates today. I'm not here to talk about them, but I want to make sure that you guys understand the range of options, and I'll try to be really explicit when we talk about mitigations, which of the tools I'm using. So, I always want to point out that our process is the security development lifecycle that Mr. Lipner has put together. So threat modeling, like we're going to do today, is something that everybody in the IE team does on a daily basis. The team is completely trained in the latest techniques, and we use penetration testing, both internal and external penetration testing, as well as code analysis tools and code review practices that help eliminate vulnerabilities. But again, that's kind of, you've heard that about Microsoft. You've heard that from Steve before, and we're going to talk about the specifics of IE. So basically, I want to give this is the 10,000-foot level view of how IE interacts with the threats on the internet and how IE interacts with your system. So if I look at Internet Explorer at the center here of the data flow diagram, I type in a URL, and I'm sending a request out over the network. Maybe I'm going to, maybe I typed in the URL, maybe it came from a phishing site, and a phishing email, and I'm sending that request out over the network. Maybe there's bad content coming back. The bad content coming back from badguys.com is the first real threat scenario, and that's really where things are going to get started for us today. So what are the things that are coming back? A URL is coming back. Is the URL safe for us to handle or not? There is HTML coming back. Is the HTML safe for us to handle? Script, there could be an MP3 file coming back on that request as the content from badguys.com. So we have to be safe as we handle that because as we handle that, we could end up writing something to the user profile, to the user system. We could end up writing something to one of our helper applications. So ActiveX controls are a great example there. So this is, at a high level, you can start to see how some of the threats would manifest. We're actually going to drill down. We're going to take this Internet Explorer process, and we're going to break it down. First thing I'm going to show you is the high-level component architecture of Internet Explorer. The stack down the middle are the Internet Explorer core DLLs that you use every time you browse. From the top to the bottom, we go UI, networking, and page rendering. Let me back up a step. So again, let's take the scenario. I am looking at an email, and I click on a link in the email. The user interface of IE is the first thing that gets invoked. If I type in an URL in the address bar, roughly the same thing, that URL gets passed by the UI down to the network request layer. The network request layer formulates an HTTP request and sends that out over the TCP/IP stack. The request comes back. The network request layer effectively triages the request and says, is this HTML to go to our page rendering layer, or is this an MP3 file or an exe file? If it's HTML, the network request layer sends it to the page rendering layer. We make a web page, and hopefully it's a good one. If it's an MP3, we would hand it back to the user interface, and the user interface would then throw a dialog to prompt the user saying, do you want to run this MP3? Maybe the user has installed an MP3 player that's registered itself as, hey, I'm safe, I can handle any MP3 from the internet. And that's a case where the user interface layer would still decide to hand it off to maybe it's Real Player or Winamp. But that's where that decision happens. So now I'm going to drill down into each of these three layers to identify the threats that manifest in each of them. So here, basically, I'm going to, for the purposes of a high-level threat model for the UI of IE, I'll call the UI, those top two DLLs, as trusted, and I'll say, you know what? For the purposes of identifying threats, I'm going to defend myself in depth. I'm not going to trust the other two pieces of the stack. I'm not going to trust this network request layer that could send me garbage, and I'm not going to trust this page rendering layer. So again, I'm a user. I type in an URL, or I navigate to a website that was sent to me in email, and my request going out is the green URL request here, and the network layer sends me back some garbage. It sends me a redirect to an URL that I wanted nothing to do with. And because of that, maybe the network layer has misinterpreted the URL and sent me the wrong domain. Maybe when I receive the URL, I perceive the wrong domain as that user interface layer. The URL could be some gargantuan string that's looking to probe some memory allocation error in my logic. Those are threats. I'm not saying these aren't bugs. These are the threats that Internet Explorer must be robust against in order to be secure. I want to make sure that that's clear. And in fact, we're going to find out later how we mitigate them and that there are indeed vulnerabilities here. But I want to make clear that we're going to walk through an entire kind of list of potential threats, or at least a good high-level sampling. Another threat is that the UI gets the URL, and the user can't read it. It's an IP address. They don't know what to do with it. They make the wrong decision. That's a threat that we have to deal with in the user interface. There's the possibility that, like I said, I got that MP3 file back, or maybe it was an exe file. Maybe it was an ActiveX control. And the user sees the prompt, and they just say, OK. And we all know that that's actually one of the common ways that spyware gets installed. So we know that that's a real threat. We know that there have historically been vulnerabilities where the exe file comes back, and the prompt looks at the exe file and says, that's an MP3 file, and tries to load it in an MP3 player. So that's another threat in the return of a dangerous file type. Another interesting threat is that those are the threats that come out of the network request layer back to the user interface layer. There's also an interesting threat that says the page rendering layer has loaded all this HTML, and the HTML is from badguys.com, and it wants to throw a pop-up window. And the page rendering layer calls the user interface layer and says, hey, put a pop-up window over here on top of my address bar. Put a pop-up window over here on top of your cancel button on the download a bad file prompt. And that's a threat as well. So the page rendering layer can introduce threats to the UI, just like the network request layer can as well. Last threat that I think is really important to talk about in the UI space, the user lowers their security settings. The user goes to a website. The website says, we're sorry. Your security settings are too high. Please go to Internet Options and set them to low. This seems insane. I find it shocking and horrible. And yet, some of my management's family does this, and then I find out about it. So I know it's a real threat, because those people call up and, I have XPSP2. Why do I have spyware in my system? And we go and we look at their Internet Control Panel. Well, let's see. This whole low thing, not a good idea. So it's a threat. We'll talk about mitigations later. Threat modeling means I don't talk about fixes until I've got the whole list. OK. All right, the network request layer. So the network request layer is going to be sending. This is kind of our launch pad to badguys.com. So we pack up our network requests that might carry important things like our credentials, cookies, things like that, and we send it off to badguys.com. I actually want to clarify that this is not that the credentials being cracked or somehow parsed out of a request is not as interesting a threat for us at this point, so we won't spend a whole lot of time on that today. But for the purposes of being complete, right, the first thing that goes out, my request goes out, and it has something interesting on it. Maybe somebody's going to try and go after that. So,
ask a clarification. When you say it's not interesting, that means?
That's a great question. So the threats that I'm presenting today are, like I said, I'm being complete in presenting the threats based on how the data flows through the component model. But I want to flag out items that we won't come back and talk about mitigations for, right? So specifically, when I say not interesting, it simply means like don't expect to see me have another slide later telling you how we're going to change the way authentication works on the internet in IE7.
It's list of what's interesting and not interesting are because there's been the greatest problem there, and there's been the least problem, so it's not interesting. What makes something?
So that's a great question. And when you say greatest problem, in the threat model process, we define problem by I came up with an idea, like I decided, hey, auth creds could be at risk, and then there's some follow-up on that. So it might mean that a developer and a pen test team goes out and beats the hell out of that code path to decide if there's a problem there. And if they come back and say, you know what, we've exhausted all possibilities, we think this architecture is robust, don't, we're sick of beating our heads on the wall. We can't find anything here. That's when we say we don't think there's a problem there. Okay. And then it's really nice if there also happen to be no publicly reported vulnerabilities there as well. Generally, those two things go hand in hand. So that's why we're not going to talk about, specifically, we're not going to talk about auth today.
So can you just also speak to what makes you think that each of these lists is complete?
Okay, great question. I don't think that each of these lists is complete. Okay. These are samples.
Okay.
If I walked you through all of the threats that we brainstormed for IE, you know what? You guys would basically move to Redmond for that. Because we've got a really, really long list. This is, when you do threat models, remember the first data flow diagram I showed was super, super high level. And what I've done is I've taken the zoom in one notch, just one notch. So we call this effectively the first one was a component level data flow diagram. And this is like a level 0. And Dave will tell you, Dave Ross is one of our sharpest security testers in the company, frankly, and particularly a specialist in IE. Dave will tell you that he has seen data flow diagrams down to level n where the first character of n is not a triple digit yet, but barely. So we've got really deep threat models and we have really deep data flow diagrams. And I'm going to go over each of these is like a big bucket. Each of these threats I'm outlining could have 50 different variations and nuances, and we could actually spin up a test team to go look at each of these for a month, basically. Does that answer your question? Okay. Sometimes longer than a month. So that brings me to my next one. URLs parsed incorrectly. We've seen this threat before in the last slide. Interesting. So if I parse a URL incorrectly in the network layer, I might make a mistake, like I might not enforce the correct security settings. So the network layer is actually where all of the that slider that you've all seen for security, the decisions that we make that we enforce based on that slider require the network layer to parse the URL correctly and decide which security zone that domain is in. So if there's a mistake there, that's the type of threat we could see. That could lead to an ActiveX control being loaded with lower security and less scrutiny. So another thing that we do when the content comes back to us, so like I said, we talked about the auth credentials going out. We talked about what happens when a URL comes back to us and it's bad. Well, the other thing that comes back to us is data. And the network request layer is responsible for triaging that data and deciding where to send it. Do I send it to the page rendering layer? Or do I send it back to the UI to let the user decide what to do with it? And what it does is it actually sniffs the data. It looks at a content type header from the web server. It looks at the first 200 bytes of data from the file and says, is this a web page or is it not? And basically, there are a couple of things that could happen there. Either I could buffer overrun that data sniffer, because that data sniffer has to be familiar with like the top 26 types of data that I could download. So there's attack surface there. Or I could basically trick that data sniffer by putting something that looks like HTML in the first 200 characters of my file, and then something that's really an exe by the time it gets to the page rendering layer. So another thing you'll see here is that we've got pluggable protocols on the side with some orange requests going back and forth. And pluggable protocols are potentially extensibility written by a third party. So Outlook has written a pluggable protocol. You know what? Honestly, like with any extensibility, I can provide guidelines to folks who write extensions. But to some respect, when they're running binary code, I have to consider that data as untrusted. And they're as responsible for security as I am at that point, because they've introduced potential vulnerabilities. Now, that's until I change the model for extensibility. But with the model that we have for extensibility today, if somebody's written a pluggable protocol, then they have a responsibility for all of the threats that I'm responsible for. OK, so the network layer looks at the data, thinks it's HTML, and sends it off to the page rendering layer. And we're all hoping to see a pretty web page. But what could come back? Well, we could get a malformed URL again, third third place in the stack, we're worried about URLs attacking us. Buffer overruns are common. That's something we're worried about everywhere. That's a potential threat everywhere. More importantly, in the page rendering scenario, if URL parsing fails, then we could have a page access rule failure. And imagine you go to fidelity.com in one page, and you go to badguys.com in another. And badguys.com is trying to use script to just create an object or access an object in the fidelity.com page. That should not be allowed. That should be blocked. But if the URL is parsed incorrectly and badguys.com tricks us into thinking they're from fidelity.com, then they could potentially access objects on the page of fidelity.com. So page access rules are one of the number one things we're looking to protect in the page rendering layer. And URLs, again, they could bite us here. So another thing that could happen that we've seen historically is that the HTML that comes back to me, maybe that's bad business, right? Maybe that is going to try and attack me by exploiting a memory error and causing a buffer overrun. And another thing, has anybody here heard all this stuff about IE before? Cross-domain, HTML buffer overruns, ActiveX controls. So folks who followed some of our history of vulnerabilities will know that these vulnerabilities aren't just brainstorm threats. They're very real. So ActiveX controls, I've got these as orange here. Sometimes I feel like they're red. The fact that the user installed them or that someone put them on the machine is what's granted them trust. But really, they can, again, they're responsible for all the same threats that I'm responsible for. As core, the core IE component, I load an ActiveX control and share data with it. And that ActiveX control is responsible for all the same security responsibilities that I have. It can call me and ask me questions, and maybe I can help it make an informed decision. But generally, that control has to at least be aware and sentient enough to think about these threats and interact with me to get the right information. So we've seen ActiveX controls that buffer overrun. We've seen ActiveX controls that misparse URLs. We've seen ActiveX controls that allow these page access rules to fail. So again, they have a great deal of responsibility when they write an ActiveX control. So the last threat, I started with, I'll do it over here because this one's confusing. I started with threats on the URLs and HTML that come back. Then I talked about how ActiveX controls basically have the same responsibilities. And the majority of this page access issue that I've discussed happens because of script. So again, I've got a page that's rendered. I launch some script from that page, and I try to talk to another page. Is IE going to make the right decision about whether or not script gets to talk to page 2? Does IE make the right decision there? So historically, threats that you can imagine are that the page rendering engine might have an unsafe default in one of its logic choices. Another interesting scenario is what happens if there's script out there running in the script engine and the page that's running in the page rendering engine changes? What if it redirects? So the scenario is I go to badguys.com. Badguys.com launches some script, and it sits there with a timer, and it counts to 10. Meanwhile, badguys.com redirects itself to fidelity.com, right? And the script is 7, 8, 9, 10. Comes back to fidelity.com and tries to access an object from fidelity.com. And you can imagine that if the script engine and IE and the page rendering engine don't enforce that page access rule, that there can be information disclosure, and there can actually be elevation of privilege depending on what zone the page access rule fails for. So I think I've actually passed the 20-minute line, and that's good because we've got through a high-level threat model of IE. We've talked about the 3 layers, the UI, the network request layer, and page rendering. I want to make sure before I dive into mitigations that I give you guys a chance to go back and hit me with a couple of questions about the threats. Go ahead.
How how do you take into consideration other components like Outlook that interact with IE security settings? Because Outlook has its own, and you can get some feature interaction.
That's a great question. The question was, how do I take into account other applications that interact with?
Because the MS HTML renderer, for instance, is shared.
So generally, I would treat other applications that host Internet Explorer, like Outlook for this in this purpose. When we went back to, if we go back to the architecture diagram here, if someone is hosting IE, then they're effectively taking the role of the user interface layer here. So Outlook effectively takes on a lot of the responsibilities that our UI layer takes on. So, for example, Outlook has to decide if they want to run exes that come back from the network layer.
I guess the question is, whose security settings take precedent?
That's a great question. Whose security settings take precedent?
Do you talk to Outlook people and you agree, or you
so we expose all of our security settings programmatically, and they can either choose to use defaults from IE, or they can choose to apply their own. They can say, and this is a great example. When you get a piece of web mail, HTML email, that HTML email is coming from www.badguys.com. And if you were looking at www.badguys.com inside of IE, that page would be able to use script, and it would be able to use ActiveX. Outlook overrides that because that email got pushed to you, and you didn't choose to go there. So that email could be trying to use script and ActiveX to do something bad. So even though the page that you're looking at in Outlook came from badguys.com, which is internet, Outlook treats that as restricted sites. And that basically increases the security on the HTML email that you view. So they override our security settings in that case.
Is there a case where it goes the other way?
Where they downgrade our security settings?
Well, no, where you override. I'm just thinking from the user's point of view, if this is a consistent experience that Outlook always overrides IE or...
So Outlook generally takes the IE security settings and increases them.
Okay.
There are no mainline scenarios. I can think of a couple of corner cases that would be very difficult to explain and not very clear, where there's a little bit of back and forth. But generally, the rule is that Outlook is going to enforce higher security or the defaults for IE.
And that's a general question, of course, with any other...
Yeah.
Right.
There are a ton of WebOC hosts. We call the browser, when it's used as a COM object inside of another application, we call that the web object control. And any application that decides to host, i.e. is a WebOC host. So Outlook is a WebOC host. AOL is a WebOC host. There are a number of Windows applications, like the Microsoft Management Console is a WebOC host, and there's a really long list. So, actually, Netscape, when Netscape switches over to using IE mode, they themselves become a WebOC host, and what they do is they put themselves in as the UI layer on top of the rendering engine and the network request layer, and that's the way that Netscape can change the settings for script and ActiveX dynamically, because they can say, IE, we want you to do this on this page at this time. So it's actually very, very powerful and flexible, and that's part of the reason it's been so popular with folks who are rebuilding their own browser. So I want to that brings up an interesting issue that I should clarify. Sometimes we mitigate threats. Some of the mitigations that we've implemented here are going to actually be specific to IE, and this is actually the best exception to your question. In XPSP2, we built things like a pop-up blocker and window restrictions and manage add-ons, and those things were all specific to IE because we knew that if we changed all the rules on everyone in a service pack, we would break all of those applications that host it. And what we did, and Dave will probably look up and start smiling at me, is we created an opportunity for every application host to opt in to using those XPSP2 mitigations. So an application has to raise their hand and say, I want to be part of local machines on lockdown. I don't think pop-up blocker is an opt-in. I think you have to write your own pop-up blocker. I want to be a part of window restrictions or MIME handling or object caching. I want that feature. So it's important as I talk about these mitigations to call out which ones apply to everything and which ones only apply to IE. A great rule of thumb is if it's an architectural change, then everybody gets it because there's no way for us to turn it off, right? It's like we replumbed everything and there's absolutely no way for anyone to get out of this behavior. If it's just a mitigation where we're kind of changing a default potentially, then that's something where we can have a logic switch and say, oh, you don't want to have local machines on lockdown, or you do. So that'll actually go back to this whole architecture versus mitigations question. Okay. We'll talk in order the same way that we talked about the threat model here. I'm going to start talking about threats to the user interface. Then we'll talk about threats in the network layer, although there's a little bit of crossover there. And then we'll talk about threats in the page rendering layer, and we'll wrap up with kind of how we're mitigating threats generically. So buffer overruns and low rights IE are generic across the board, wrap everything mitigations. I'll just dive in here. Okay, so the first thing, one of the threats I mentioned was that a user is going to look at a URL and not get it. They can't read the URL. I also mentioned the threat that that IE might somehow dynamically screw up parsing of the URL. So, and the user gets phished. And the result of the threat, user gets phished, bad things happen. I actually want to show you the work we've done in IE7, and this is the beta 1 build that went live yesterday to MSDN subscribers. So I'm going to show you how we block a potential phishing attack. I'm going to show you how we deal with sites where we're not sure, and I want to show you how we try to reinforce a positive experience on more trusted sites.
Bob, you're going to cover up, because I mean, the interesting challenge is that if you're going to provide information or even block somebody, it means you've actually looked at where they're going, which is inherently a privacy trade-off. So
Bingo.
You're going to cover off how we've dealt with that?
Notice and choice, right? Where's Ira? Notice and choice.
So blame Ira. Yeah.
That's right. So the first thing you see here, before we get into the phishing filter, is this prompt, and it's asking the user's consent. It's asking the user, hey, do you want to get involved in this phishing filter? And we've tried to present this in as plain language as possible. This is a beta. We're accepting feedback. We found that we think people do understand the word phishing, and one of the things that we want to be clear to users here is that this is for their protection, not for any other use by Microsoft. So for the purposes of the demo, I'll pretend I'm not a privacy freak and opt in. And
You freaks.
And who's this guy? So look at him. All right. So so the first thing I do is I'm looking at Outlook. I'm enjoying my coffee in the morning, and I click on an email about my Microsoft billing account. Uh-oh, what happened? Well, what happened here was that I clicked on the link to this billing account and was completely convinced that that was really my billing account. A couple things happened in the background while this was happening. As IE finishes the navigation, it made the request to a web service to check if there was a known issue with this URL. Now, the reason it did that is because it detected through heuristics that there was a reasonable chance that something was going on here. So the domain name isn't very straightforward. So it was, this is a good time to go check the list. But also, this domain name, this IP address, wasn't on kind of a list of sites that have all been reported as good. Because I've got a list of sites that have been reported as good, and that's been cached locally on my machine through Windows Update. So it wasn't on the good list of sites. It's got an IP address, a little sketchy, and it's got a bunch of forms in it. maybe we'll go check the service and see what the service says. Service returned, this is a reported phishing site. Someone has been doing crime with this website. And as a result, we can take very assertive action for the user, navigate them away from the site, and say, do not go to this site. Again, this is kind of a beta of the user experience. One of the things you'll see in beta 2, hopefully, is that the entire address bar will fill red in the background. So it's a more dramatic kind of warning to the user, so they know there's something going on. And one of the things, a couple things I can do here, I can say, you know what, this is my website. Damn you, Microsoft. This is not a phishing website. Leave me alone. And then that report would go into a queue and get triaged, and effectively within some short period of time, we could correct the service and make sure that somebody who's been reported phishing is actually not being slandered publicly. Okay, so I actually can also continue through to it, and a couple of the things you see on the site, looking for my credit card number. Another thing it tried to do is it tried to draw some HTML over the address bar, and you can see that IE has blocked it from drawing HTML outside of its own client area. It actually shouldn't be drawing on top of the file and edit menus either. That's a bit of a bug that we'll be fixing. But the point of the matter is that it wasn't able to draw itself over the address bar. Okay, so let's see if I can get to my favorites menu. Nope. Okay. Well, so I just told you that this whole thing is dependent on a service. And that should raise a little bit of an issue with security folks because, well, that's great. But what about the sites that you don't know about, Microsoft? You have a service, but it's never going to be complete. And unfortunately, this is subtle because of because we don't have the address bar filled yet here. But this is a site that isn't listed on the service. It's not a known good, and it's not a known phishing site. But the heuristics on the client, which we can update in the same way that we can update our spam filter heuristics, say, again, it's got that IP address instead of a real domain name. It's got forms asking the user for information. Something could be going on here. And since it's not listed in either place, we can go ahead and report to the user, this is suspicious. Now, we won't navigate them away from the site, but we will provide this warning, and it'll be more dramatic in the address bar. This is where that kind of entire address bar filling yellow will really matter. We need to get people's attention here. So now the great thing is that this can be, we can use the community to make the service better here. Because if I'm a halfway savvy user and I stumble on one of these things, I know this is bad. You know what? And now, if I've got IE7, I'm not afraid to go to these things. I'm not afraid to go to these sites anymore. I'm kind of anxious to go and see if I can, report them and get them put out of business. So this is actually the live experience that you'll see. If I decided I want to report this as a phishing site, I come through here and I say, I have reason to believe this is a phishing site. Well, what if somebody started hitting that with a web server and trying to poison our data and saying, you know what, Microsoft, all Microsoft.com sites are phishing sites. So as soon as this navigation completes, what we'll see is the user experience that we've created to prevent poisoning of the service. And really, there we go. OK, so anybody who's ever signed up for a Hotmail account has seen this. There's an acronym for this, Human Interface Detection, HID, I think. Somebody smarter than me should know, but 29SJ, can help please, 9RL.
You left the U out.
Okay, so we've clearly got usability left to do on these. Actually, I think we're done.
Yeah.
Okay. But actually, we've got. I wonder if the audio is going to work here. Let's see if we can get the audio going. But for folks who are, like me, who apparently can't figure this out. So we've got this set up. I'm kind of playing with this feature a little too much now. But you get the idea that by blocking people who are just trying to spam the service, we can get better data into that service. So the last thing I want to show you is a positive reinforcement about a site that we actually trust. We're going to a site where they've at least got all my email. And luckily, they've signed their HTML and their HTTP traffic with an SSL certificate. And that means that I know that some certificate authority has validated some bit of their identity. Now, one thing that should be interesting to you guys as security and policy folks is that the criteria that go into getting an SSL certificate might not be as stringent as you think they are. If I go to a certificate authority, like I won't name specific names, but I would encourage you, if you're curious about this, to go out and look for a certificate that you can get in 20 minutes for $20 that says you're Steve Lipner. Because I've got 3. So I'm kidding, sort of. But actually, the certificate authority community is working with us. They are aware that that really, right now, in the face of a phishing threat, that it's time for that industry to step up. And they've convened 2 roundtables now. We actually had one on Tuesday in Boston. 2 roundtables to figure out how we raise the criteria that are used to evaluate certificates. And when we have a higher assurance level certificate, we're going to, again, reinforce with the user by filling the address bar blue and saying this is a high assurance certificate, and we'll pull the organization name up into the address bar as well. We can't do that until we've got high assurance that the SSL is from who it says it is. But that's a huge opportunity and something that, go ahead, Mike.
When you click on details, what happens?
This is actually going to bring up the old certificate UI that we had in the old days. So really the benefit that you're getting in Beta 1 in particular is that the lock is in the address bar where it's not spoofable, right? The information about the site is accessible easily.
So the URL that's associated with the certificate will appear in the address bar.
That's right. That's right. That's to get the lock icon. The URL for the site has to match the URL that's in the certificate. And if for some reason the URL for the site didn't match the thing in the certificate, we're going to show a really aggressive warning user experience. It's similar to phishing. It's something that we have coming in Beta 2, and I don't even have a good screenshot for you, but it's working, and it's really cool. So
there's a remarkable number of Microsoft services that are operating in outdated certificates. We really better get that fixed before you release this.
I hope you do, because we're not slowing down. We're not going to wait to ship. Anybody who's got an out-of-date certificate needs to get it fixed. And hopefully, folks from big enterprises are going to go out and get these high assurance certificates as soon as the certificate authority community makes them available, which we're hoping is really, really soon. So, okay, that's basically kind of a high-level overview of kind of the anti-phishing filter and some of the improvements we're making to SSL. Another threat we talked about when we were walking through that threat model was the ability to overlay a piece of UI with some HTML that came from with a window that came from the page rendering layer. Right? I've got my UI layer, and I'm going to throw a security warning.
Can I just go back to that last
Sure.
discussion for just a minute? So if somebody's trying to go after Microsoft's websites, what happens is you're adding to the known good list over time? Right?
That's right. That's right.
And then if somebody's on a known good list and that gets somehow converted into a bad guy, how does that get handled?
So it's a great question. The question is, we have a known good list that's cached locally on the client, and we update that monthly. And the scenario is, let's say robfranco.com just goes evil, right? He goes off the deep end, and all of a sudden he starts, phishing attacks on all of his users who formerly, were giving them his credit card information, which they should be doing. And when we find out robfranco.com is a bad site, but it's on this good list on the user's machine, we haven't run into that circumstance yet, but the plan would effectively be we would need to go update and enforce an update for users that they would get a updated list of that. Of the known good list on their machine.
So can you talk a little bit more about that? Because I think that it would be helpful to know how we're thinking about for the people that are privacy freaks, how we can still provide to use your word.
Sure.
Hey,
I was referring to myself, not to the community here. I mean,
We've been called worse.
Are we trying to provide protection through choice to the people that may not trust us?
It's a great question, and I'm hoping that I can actually demo that today. So let's say I go back to my home page, and let's pretend that when that prompt came up, let's pretend I clicked no, I don't want to use that crazy Microsoft thing. They're after me. If you're Rob and you work at Microsoft, you could say, my manager is watching where I go. It's probably true. So here what I can do, now when I click turn off automatic checking, that's the equivalent of having clicked no on that first prompt. So now what's going to happen is, let's say I go to a site that's off of the list, and this should now not block. It doesn't block, but it does a couple of cool things. So one thing it's done is it's given me an icon I can use to decide if I need to, hey, reminder, there's a little anti-phishing thing. Oh, you know what? I'm a little worried about this site. I'm a privacy guy, so I never turned that thing on. I never turned this anti-phishing filter on. But before I put my credit card into this, I'd like to see what Microsoft has to say about it and what all the users that have been using the filter have to say about it. So then I could go and say, and here for the people are concerned. They want to know exactly what they're sending. So we'll again give notice and choice before we send anything. And I'm going to actually want to see this again. So really quickly, you saw that progress bar. That progress bar running was the act of calling the web service again and retrieving that known bad information from the web service.
So do we really think that people are going to notice a funny little squiggle on the SSL bar unlock, or are we, and I realize it's beta 1, are we planning a different user interface?
So the question was, do we think that people are going to notice this little icon down at the bottom? And in the old days, I would have told you yes. I mean, clearly, that's where we put all of our status icons. I think
you're growing a lot more stupid recently.
That's right. That's right. No,
user. Duh.
So I think that's a good question. There's some discussion about where the right place is to put it in the UI. If we wanted to make it super prominent, we would put it up in the address bar. And I think there's a trade-off for folks who we have to decide what the right level is. We have to decide if people want to know every time something's not on the known good list. Like, are they going to feel uncomfortable about the fact that there's a known good list even, right? You can disable the known good list if you want to, but that's...
There'll probably be some opinions on that.
Sure.
Can you connect to someone else's known good list site?
No.
Is that a feature?
Is that a feature? It's not. It doesn't... We're not doing that.
No, is it a feature that you can't?
No, it's a
Did you design it in purposely to make it impossible for someone else to provide a known good list site?
To somebody else that you thought you trusted.
I want to ask, to follow up, when you're spinning this back and it says phishing filters determine that this is a reported phishing website, one of the things that I think is really potentially powerful in the dealing with the phishing kind of stuff is, your mom, dad, and sister all got scammed here. The power of the people and so, are you contemplating saying, 350,000 people have reported this site? You know what I mean?
Yeah.
Because I do think that's the kind of stuff that you need to get people to pay attention. People on your network have complained about this.
Yes. Yes.
But then the corollary is, I actually think it would be really useful to be able to, like everybody else here, I'm even me, who's not particularly computer savvy compared to the rest of you. When I go home, my mom, my dad, my step, they're like, "Can you help me? Is there a list of sites I should be avoiding?"
You imagine what he gets.
I can't even imagine what you get. But I think it could be a really cool feature to be able to say, here's the list of sites that today I think you should stay far away from. If you've seen Bank of the West, don't go there.
Yeah. So
the collaborative filtering, I think, actually has a lot of potential in this space, which you may too.
So what I think I hear you saying at a high level is, how can we enrich the user experience with more details about the feedback that we got.
Yeah.
Whether they be numbers of users reported or comments.
Or maybe even think about where they can get feedback from differently. You know, could it be an internal network feature? At Berkeley, I can find out, 350 people reported this particular thing to our system administrator.
Yep.
Speaking as a security guy, I worry that if he opens up, the sourcing for the back end reporting, he creates himself a worse security problem. Because my holy grail then is to spoof that bad site list.
Well, right, and that was my other question. I mean, you could imagine people gaming the system the same way Google and all the search engines have gaming, only with the converse desired result.
I mean, I'm thinking of something worse. I'm just going to replace. I'm going to make you refer to my service, which says that evil.com is a good site. No.
Yeah.
Why would I do that?
So I want to. First of all, I want to thank you and accept the feedback that there's value in adding data from the community. I agree with that completely, wholeheartedly. I'm going to turn to Mr. David and ask you to be my official note taker.
Not a problem.
Awesome. Okay. I don't want to lose any of the feedback that we're getting from this.
Oh, well, as a general rule of thumb, people sort of make sure that, it gets to me. Yeah.
Okay.
So, no worries.
Well, but now I've pinned it on you.
Exactly.
Okay. So.
Can I ask?
Yeah, absolutely. Go ahead.
How do you check, arbitrary? How do you detect arbitrary number of users sending you something? This is a suspicious site, but may not be. How do you, when somebody reports to you as a suspicious site, how do you take it in, or how do you detect?
There is a human review process and a set of graders who will actually go and review the sites that have been reported and try to determine if they're actually phishing sites or not.
So I could get 100 people to just send, this is a suspicious site, and there will be a human process of
There is a human process that prevents it from being used ill. And the other thing, like I said, there's a human process that helps protect us against either case, right? So either that I'm reported good and I'm actually a phishing site, or that I'm reported phishing and I'm actually a good site. So we call it our escalation process. If we somehow get it wrong either way, there's one single repeatable process that we expect to be reliable that will help us get the service corrected and the right data up. So that's actually really key. Like, please do not call me. Please do not call Bill Gates. Really, don't call Bill Gates and ask him to call me, because that would be good. Instead of doing that, use the report that it's not a phishing site option here, because you saw what the user experience looked like. And if you don't see results in a couple of days, then call me. And a couple of days later, then you're free to call anyone in my management chain, one at a time, preferably not Bill Gates. Go ahead.
Instead of calling this an anti-phishing device, why don't we call it a pro-censorship device and have, let's imagine, the Chinese government getting all Falun Gong sites on the list, or to what extent have you sort of played this really valuable tool, which is trying to reduce phishing, and sort of gamed out in the hands of Singapore or China or other countries this as a technique for really effective censorship?
How about there are easier ways for them to do that don't involve Microsoft reviewing every site they try to put on the list? I don't know.
Oh, I don't know. I'm asking that as a question.
Aren't you guys going to review
question.
I mean, it's a sort of different.
We're going to review the sites that we put on our list, right? And this is a great reason to make sure that our service uses our information, right? Because if the feature could just be kind of jam full of other random info, like I just change a URL run some script on my page, or like talk to a proxy server, and all of a sudden, I'm getting phishing sites reported by the Chinese government rather than the Microsoft reputation service, and I got a problem. And luckily, the browser architecture has a solution for us. So the communication out to the web service is all over SSL. So any results we get back have to come from the domain name that we that we like. It has to. It's signed traffic. It has to come from urs.microsoft.com, and if it comes from anyplace else or signed with the wrong certificate, then we're going to reject it and say, you know what, sorry, this phishing filter isn't working right now. You need to move out of China. Or
so this answers the question from earlier, which is why not give people a choice of 10 different providers? That would create a vulnerability for either China as censor or for bad guys to be using this as a filter that people wouldn't want.
There are two different things. I mean, I assume that China would put out its censorship site, and it would be a legitimate, authentic site. That's one issue. And then the issue that I was actually more worried about was somebody using the extensibility becomes a target for evil.com to put up its own list of non-phishing sites, which is a list of phishing sites.
Yes. So I can't imagine how much fun the guys who run that urs.microsoft.com server are going to have. It's going to be... Actually, I can't imagine because I work with them very closely, but it hasn't been attacked yet, so it's going to be fun when this starts getting attacked.
Isn't it just a simple denial of service attack? Where I just flood you with information?
Are we getting all this? Okay, good. I want to make sure because I like...
No. Let me explain the process to you. Basically, these folks are at the end of the sessions. If they have individual session commentary, they usually write the notes down, and then also at the end of the entire thing, they give written feedback back to me, which I parse out to.
I'm gonna be more greedy than that and say that I need to borrow a pen or something because I need to get all these down.
Taped as well. So.
Oh well, that's great. Okay. Cool. Go ahead. Sorry.
Isn't there just a simple denial of service? I'm a phishing site. I don't want my phishing sites to be logged, so I just send you loads and loads of information to stop the real, hides the real reports.
That's a great question. So I'm a phishing site, and I want to try to basically attack the service with fake information that I'm a good site. And that's when we walked through that report.
Not to tell you that I'm a good site, but just to give you so much information that you can't process it.
Just DDoS the server.
Got it. So not even kind of a well-formed poisoning attack, just a straight-up, brute force DOS.
Well, if you've got a human scan every report, it's not going to take me long to do that, actually.
So remember that the web server will throw away reports that don't have the HID verification in it. So if you walk through that site where we reported something as phishing, you have to walk through that experience, and you have to get that crazy picture that I tried to work through with your help. You have to get that right before your data is going to be valid on the web server. So you can't poison the service unless you find a way to crack that process, which clearly could happen, and that's why that picture was so insane. But we wouldn't expect that would happen.
Chris, that's the way that now anybody that signs up for a Passport account has to do the same human thing to prevent the mass sign-up of email accounts for spammers?
You don't have any way to trace back bogus reports to the source because you don't pay attention to you don't authenticate the source of one of these things.
So the question was, do we have a way to trace down bogus reports? And I think you're right. The answer is no. We don't have a way to trace down bogus reports.
That's because privacy is trumping expediency.
Because privacy is trumping expediency. Also because you remember that users could basically come from any IP address in the world, and we're not going to be able to track down their information. We're not going to be able to. We could request people provide some kind of email address or something, but even that we know doesn't provide real accountability there. So right now, your point is very valid. We're depending on the grading system and the escalation path through the grading system to kind of calibrate the data correctly.
So some sites use the trick of you sign up, you give an email address, they send you back an email that has a link in it that you have to click to validate your sign up.
That's right.
And you can do the same thing. At least you'd have an email address you know they were at.
That's right. That's a great point. So in order to make sure that the data is reputable. In order to make sure that we know who the data came from, we could actually try to verify email address. Now, again, the situation there is, how hard is it for me to get a fake email address?
Yeah, I understand.
Because I've got 3 or 4 And like, am I even using the one that the
Even provide a service that hands them out for free.
Exactly. So I think there's some additional level of protection there, but I think what we're seeing right now, at least in the beta, is we're betting on the service and the escalation path to be successful.
So presumably you've talked to the lawyers, and you're comfortable that you're not going to get sued by the sites that you incorrectly list as phishing.
The lawyers worry about that.
Yeah.
Yeah,
They do.
I'm a specs and product guy. So, but again, like what I can tell you is that that's the reason we have the escalation path.
Yeah.
And that folks who have an issue with the service should hopefully be able to get that issue corrected.
And Ira's providing, I mean, he's left, but Ira's the type that would provide the scrutiny on this type of stuff and basically give guidance as to what would be ostensibly legally acceptable. So,
Any other questions about the anti-phishing filter?
Seems like this is going to help some. It's good.
Yeah, absolutely, absolutely. So, okay. So,
Are you going to make it available to people who aren't using IE?
the question was, are we making it available to people who aren't using IE? And this is an IE-only feature. And
There's services out there.
There's services out there.
Presumably, if the protocol isn't public, it will become publicly known.
It will become public later this afternoon.
No, I mean public, like even if you guys don't announce how it works.
It will be reverse engineered, is a more accurate way to say it, later this afternoon, because this feature is now live publicly, right?
Okay.
So if this thing is reverse engineered, right, if and when this thing is reverse engineered, at that point, if someone decides to implement a phishing filter on the top of that data, they would be doing two things. First of all, they would be assuming liability for any user experience they present to, and again, I'm not a lawyer, but reasons I wouldn't do it if I were a program manager at, Phishing Filters R Us, is because I wouldn't want to put myself in a position of, just blindly consuming data from a third party, right? Which is what you would be doing if you're hitting the URS without having any idea where the data is coming from. So I'm Phishing Filters R Us, and I build it.
I'm not Phishing Filters R Us. I'm Netscape. I picked
Sure.
some name, and I decide to build the same functionality into the Netscape browser that's in the IE6 browser, and I say, look, you can do it in IE. We do the same thing in Netscape. In fact, we even use Microsoft's list.
I don't know how that would work out, honestly.
Channels. There's lawyers for Microsoft would have some pretty good arguments that Netscape was basically trespassing on Microsoft's
Well,
server.
I think you're looking at it the wrong way.
Or they might like it, but
Honestly,
I think Microsoft might want to get the credit. Say, yeah, we're doing this as a public service. The more browsers that are sending bad URLs to you, the better off it is for your company.
Absolutely.
And I don't think it's a feature that's going to make or break the sale of IE. So maybe you want to rethink this and go very public with how to use it.
I think that's good feedback. And again, that's why we'll probably be hearing and working through that as the beta goes out. That's good feedback.
okay.
You can make me watch.
By the way, Fred doesn't let anything slide.
Okay.
Way, so he will definitely let me know.
You're not going to make me watch a video of myself to get feedback, are you? I don't want to do that. That's a bad idea.
No, they move the camera and you get to see the facial expressions of the people who are listening. And you wish you were looking at
The winces in pain. Come on, Fred, give me some slack here.
So we have a server over in Supply, and we'll put it up live.
Yeah, live streaming for everyone over.
Do you guys want to, talk about security threats here? Because that's what I want to talk about. Come on, let's keep going. We got a long way to go still. Okay, so back in the world of the threat model, we had the UI layer, we had the network request layer, and we had the page rendering layer. The UI layer can receive requests from the page rendering layer, where the page rendering layer says, put a little HTML window with no border on it, someplace scary. So here is a scenario where I go to a site and it tries to spam me with a dialog and it tries to throw some HTML on top of the security decision that we wanted the user to make. That's bad, because what that site is doing here is it's basically forced the user to click yes. They have no other option. This is a modal prompt. And it's lied to them about the decision that they're about to make. So this is something that is, SP1 era. And wait, I need to move on. All right. So in XP-SP2, you started to see that scenario go away. So here is, again, what I was showing you before live with real code is XP-SP2's era mitigation, blocking that HTML from drawing itself on top of important IE UI like the address bar where people need to be able to see the domain they're going to. It also prevents Windows from drawing themselves larger than the screen, so I don't get what looks like the login prompt that's really from badguys.com. It forces the status bar on all pop-up windows, and it defaults to on in the main browser window. And I already talked about borderless windows covering UI. Okay, so that's XP-SP2. We've got more to do here because pop-up windows still don't have address bars because I can draw a scripted alert window, a scripted alert message, and I can make that message be larger than the HTML that called it in the first place. So this is a screenshot of something you'll see in Beta 2. And what this is a micro address bar that's not editable on the top of a window that previously had no address bar at all. And Sony Corporation or Visa or whatever, that's actually not a suspicious site. So please don't read into that. This is just a screenshot from the spec. But the idea is that a micro address bar, not editable, present on top of Windows. So if you've ever used Outlook Web Access and you type and you get a new email message, that's going to have a micro address bar on the top, which is kind of the negative part of the experience compared to this, where hey, I've actually been protected and I know a little bit where this thing's coming from. Go ahead.
So there's some way to get to certificates through that, or? Yes.
This location where it says suspicious website here, we call that internally we call it the trust badge. In Beta 1, we're calling it the security status bar. And as a user, you can click on the security status bar and get either the SSL report, or you can get the suspicious or confirmed phishing site report. Right. If it's a suspicious or confirmed phishing site, or if there's a certificate error, that's going to override any positive feedback about an SSL certificate. And I think that makes sense. Yeah. Right. So I'm sorry. I think there's another question about the mini address bar, the mini non-editable address bar. Somebody else raised their hand, and okay. So another issue that we've got, we're adding tabs in IE7. Great that we're adding tabs. Everybody loves tabs. The other browser vendors that have implemented tabs have seen security vulnerabilities in tabs. So imagine I've got a bunch of tabs open, and in the foreground tab is fidelity.com, and in the background tab is badguys.com. And badguys.com does window.alert and asks me for my password. Well, the alert throws itself on top of fidelity.com. I type in my Fidelity password, none the wiser, and badguys.com, meanwhile, in the background drains my account. Good luck to them. They're not going to get much. But seriously, there's a serious problem, and that's explicitly the type of thing that Dave has been very deeply involved in helping us proactively, using the SDL, address those threats ahead of time. So again, the principle here is that a window that shows any window that you see, whether it be a pop-up window or a window that doesn't have a border on it, or a window that's a JavaScript alert, any window that you see should either have an address bar of its own, or should be drawn on top of and not obscuring its parent window with full address bar. So that's the principle here that we're going to enforce in the user experience to prevent these window spoofing types of attacks. So again, that applies to tabs. Any questions about this? Okay. So I also talked about my poor unfortunate brother of boss, who managed to set his security settings to low about halfway through my Christmas vacation, which we ended up having an all-night email discussion about. And let's just say that experience stuck with me. So the threat here is that the user lowers their security settings, and they continue to browse around. Some website said, For you to be able to browse, you've got to take this slider to low. Now, most people look at this dialog and really have no idea what it means at all. Before joining the Internet Explorer team, I would be hard-pressed to tell you what the hell is going on here. This is not a particularly user-friendly experience. So if a site tells me to lower it, I hope that's okay. So we think that that's a dangerous threat, and that's something we have to do something about. Another thing that you see if you look at the old security levels, I don't know if I call these secure by default. We had lots of opportunities for interesting things to happen. We had a My Computer zone where anything went, anything goes, where a HTML running in the My Computer zone can create objects that really shouldn't be safe for script. That's dangerous. We had and still have in XPSP2 a trusted sites list that's by default set to low. So when there's a security threat and we tell people, hey, move this thing to your trusted sites, well, if that thing is trying to offer you the Gator installation, then Gator could be silently installed on your machine. If you decide that SportsIllustrated.com or pick a commercial site, please don't think I'm slandering a site like that, but pick a commercial site that's doing business with an ad-serving piece of software. And normally, if that site would prompt, I add it to my trusted sites list at low, and it just automatically gets installed. So there's clearly some improvements we can make here. So the My Computer zone, as of XPSP2, is set to what's the equivalent of high, and other folks can opt into that. It's important that we don't set that high for everyone, but the fact that it's set high in IE is very valuable. That's really one of the biggest mitigations in XPSP2. Dave will tell you that our security finder community, they kind of shake their heads when we did this. We really stumped them. Like I said, folks add sites to their trusted sites list, and they think, oh, well, I trust it to go there and see the web page. I don't trust it to be in complete control of my computer. So we're going to move the trusted sites list up to medium, so that when users set the internet zone to high, the trusted sites list is a safe place for them to use, instead of being kind of an unfortunate accident where they put something in there and something bad happens. How many folks' parents in this room use the intranet zone? I'm surprised. Frankly, I'm surprised. There's so many folks out there at home on the intranet, browsing around their own websites at home and, configuring settings and uploading documents. How can you not have an intranet zone at home? We know when a machine is joined to a domain. We know we have some APIs that can detect when a machine actually has an intranet that it can smell around it. So we can disable the intranet zone by default on consumer PCs. So now you step back from the slide and you say, well, that means the lowest level now is medium. And medium is what we consider safe for most arbitrary untrusted content. And that's a good thing. That means that by default, we've got a safer set of defaults. Now, we're also going to talk about a new level for Windows Vista, not Longhorn, as it says on the slide. Windows Vista is going to have a medium-high level. And medium-high level is going to apply to low rights IE. When I'm running something at medium-high or higher, that means low rights IE is enabled for that zone. OK. So what happens for my poor manager's brother? Well, I built a feature just for him. If he should ever set his slider to lower than the settings that I have chosen for him, I will notify him frequently under the address bar until he fixes it to return his settings to the correct level. Now, this is going to be manageable by admins. And I didn't arbitrarily pick the settings that I want my manager's brother to be set at. But I'm hoping he'll stay safer. And you can see how in the Internet Control Panel, this still isn't the most darling piece of UI I've ever seen in my life. But we've really pulled out prominently the idea that the user has to make a change, and we can help them make that change and guide them as they do it. OK, so we've talked about the threats in the UI, and somebody around the room should have. I'm surprised no one's asked me already. Well, what about URLs? Because Rob, every one of your threat slides started, worrying about how you parsed URLs, worrying if there's going to be a buffer overrun. You seem to have an URL complex. What's going on here? So The reason I put URLs in the middle of the deck is because the new URL parsing architecture is probably one of the is being delivered by the network request layer development team. So that was kind of halfway through our process of threat modeling. But it's being used through the entire stack. And when we talk about mitigation versus an architecture change, there is absolutely no mistaking that this is an architectural change that permeates the entire stack, top to bottom. This is, like I said, it's not just the biggest investment for the network request team. It's one of the two biggest investments that of all the work we're doing for IE. It really is an entire crack dev team re-architecting the stack here.
Are you saying in the past there will be many places where you do URL parsing, and now there's one place?
That's right.
Okay.
That's exactly right. So here, a good example. A couple of years ago, we had vulnerabilities where the @ sign used in the middle of a domain name would effectively show the entire. I'm sorry, @ sign in the middle of the URL. The whole URL shows up in the address bar, but IE reads the domain from the right of the @ sign. And the reason this is true is because of the FTP protocol. So the FTP protocol has a formation that is user :password @domain. So if I want to sign into my FTP server, I could click a link that says Rob Franco : there's no way I'm telling you guys my password @Microsoft.com. And that's just the way that FTP works. Well, we went and extended that and made it work in other protocols as well. And lo and behold, folks found ways to exploit this. So the network request layer would know the difference between the username, the password, and the domain, right? Where username and password here is good.com and the domain is bad.com. The UI doesn't. The UI has a string, and it looks at that string, and it thinks the whole thing is the domain. It thinks the whole thing is the URL. The page rendering layer looks at it and says, oh, we think good.com is the domain. That's our guess. And I'm kind of presenting this in its worst form to try and flag to you that this is something that for historical reasons made perfect sense that we would build this so that each layer of the code could consume the URL in the way that it needed to, right? And what that resulted in was inconsistency and failure of security with URL parsing. So that's been a serious issue. The fact that we have this single object now, and the fact that we're breaking it up, host name, protocol, path, file type, breaking that up into an array of these different variables, also sending the complete string, also sending the string minus the characters, sending that so that each module can go and make the right decision. This is one of the deepest architectural fixes we're doing, and really one of the most impactful if you look at the history of vulnerabilities. So, go ahead.
It seems like a component would be good to hand out to developers.
What's that?
It seems like a component that would be good to hand out to developers.
That's right. And I believe we are making it available to developers. I believe the object is available. The thing we're a little concerned about in this first release is making it available to developers and changing the semantics on them without bringing them through all the beta testing with us. So, if there's a polarity mismatch here, it's death. And we don't want to make a polarity mismatch internally. And the last thing we want to do is go and change the rules on everybody else who doesn't even get the 3 years it takes us to build Windows. Did I say that? So no, seriously, the 2 years we'll be working on Internet Explorer 7 for Longhorn. I hope. Who knows? When. Okay, so key deep architectural change. I want to talk about another architectural change, and this architectural change is in the page rendering layer. We talked about page access control as one of the threats in the page rendering layer. So, and the idea here is that if script from badguys.com wants to access your password field or the password object in your fidelity.com page that's open right next to it, well, it has to be from the same domain. So here, one of the ways you can imagine this happening is that script simply just changes a property on an object, like the color of the data. These two were both from abc.com. The property changed, the data changed color. That's so wonderful. Thank God we've got a web browser. Now, evil.com wants to change the data. Guess what? It's blocked. So that's the principle, that's the theory behind the cross-domain security.
Is that what I'm going to see as a user?
The beautiful shield with the lightning bolts? No.
The time error has occurred.
So actually, no, you wouldn't see an error like that. That's a script error, and generally script errors are suppressed, and there's a little yellow exclamation point at the bottom left of the status bar. The scenario here, though, is, remember, what you saw was evil.com, right, trying to access data and modify data in abc.com. Maybe it's trying to create a password field in fidelity.com that posts your password back to evil.com, right? So that's the scenario. You wouldn't see a script error, and it would just fail when cross-domain security works correctly. But this is a threat, and this is something that we've seen issues with. So I notice everyone has their laptop open. I'm sure everyone's taking notes, and no one's reading email. So you guys will actually be able to help me with this part of the demo. I want you to type in JavaScript :alert document.body.inner.html into your address bar. Yes, absolutely. You can use any browser you want to. Oh, I'm sorry. Before you type it in, I should tell you this first. Go to Bank of America or First Tech or Fidelity. Go to a site like that. You can go to msn.com if you want to, but go to a site, any site you want to, and then type that into the address bar.
After you're at the site, type this in?
Yeah, that's right. Dave, do I need 2 forward slashes?
You need to have it be able to see it because.
Hold on. Sorry. Can you see it now? No.
JavaScript :alert document.body.inter.
Inner HTML. Case sensitive inner HTML.
Yeah, not very good, but interesting.
Okay. So, wow. Okay. So we're seeing some light bulbs overheads, and okay. I'm not going to make everybody.
Wait, I want to do it.
Okay.
Transferring money to Rob's account right now.
That's right. Yeah. So anybody who's already gone to a banking site, thank you for doing that. I basically am going to check my account balance on the next slide, and then I will leave Steve to give the rest of the demo because I'm going to the Bahamas with your money. So
give me an Internet Explorer.
So let me show you. Some people have gotten it. Some people haven't. Basically, what's going to happen
I got it, but I don't
here.
know what it is.
I got a bunch of. Were we supposed to get scripting errors?
Big JavaScript box?
Big JavaScript box sounds right. So here I'm at a secure site. Let's pretend this is fidelity.com. And I'm going to paste that URL in the address bar and run it. And this is what you see. So what Jeff Cooperstein is also another one of our security experts who helps us immeasurably on IE security. And Jeff probably knows exactly what you're seeing on the screen. What you're seeing is that the JavaScript that we all put in our address bars got access to the HTML and the domain of this secure site. Well, shoot, like that actually could be a bad thing because what if my what if my password were just shown in the clear here? Or what if some sensitive information were shown in the clear here? Or what if when I typed in the what if I said instead of just showing the inner HTML, what if I set some in the inner HTML to a password field that posted my password back to robfranco.com or evil.com? Because that's the type of thing that I can do with script. So what happened here is that when I typed this into the address bar, the page access rules that govern the ability to view that HTML for script said JavaScript protocol allowed to see the stuff in mail.microsoft.windows.com. Allowed to see it and allowed to write to it potentially. So, I've been talking about page access rules and how important they are, and everybody should say that seems really scary. And the net is that this is actually not a vulnerability because you actually are in control of the machine, and you are in charge. You have access to see across domains. You are not badguys.com. But if badguys.com could do this, if badguys.com could construct this protocol URL and see the things that we're seeing in this prompt, then we've got a serious problem. And if I go back to the architecture diagram here, and we remembered how the URLs pass around. If we remembered how the URLs get passed around, they go from the UI into the network layer, and at some point, hey, how does the page rendering layer decide if this network request I made for a JavaScript protocol? This network request I made for a JavaScript protocol. How does the page rendering layer decide if that JavaScript thing belongs to Fidelity.com or to badguys.com? And the fact that there's no domain on the URL simply makes that very, very challenging. Historically, we've we've had a lot of great mitigations in place, but it's been a serious problem. And a lot of the cross-domain access vulnerabilities you see use the JavaScript protocol in order to realize this attack. So in IE7, what we're doing is we're transforming the way that we run JavaScript from the JavaScript protocol. Instead of sending it down to the network layer, we're basically going to say, no, JavaScript protocols stay inside of the page rendering layer, and they get downgraded into being script as if it were just in the page. And at that point, we know that that is going to force it through all of the normal page access checks with an actual domain attached to it now. So we can do a domain comparison and say, this JavaScript from badguys.com, even though it started out as a JavaScript protocol, has, now we've welded it to badguys.com. We've given it a domain identity so that we can compare it to Fidelity.com and say it's not from Fidelity.com. A difficult thing to explain. I'm getting some looks of concern, but I think folks get the idea that this is not just like HTML that runs in a page. This is kind of this crossbreed between navigation and HTML, and what we're doing, or navigation and a script blob in the HTML. What we're doing is we're downgrading it from being navigation down to being effectively script in the page. So that's one of the mitigations, or rather, architectural changes. I want to make sure that's an architectural change. That's not I opt in and I get it if I'm IE, but not if I'm a WebOC. That's everybody gets that, and there's no going back on that one. That's new architecture. Another issue is that I talked about how the script engine. I talked about the threat where the script engine is sitting there counting to 10, right? And then it's script from badguys.com, and it comes back to the web page, and the web page is Fidelity.com. Fantastic. Now it posts off all the Fidelity information to badguys.com where it wants to, and again, I go to the Bahamas. That is another scenario where we're saying any of these objects that we have access to, we're going to fail if they don't show awareness of a potential redirect. Redirect was a historic, over and over and over again, there was an issue there. And now the ability to simply block and deny access to the HTML after a redirect has happened on that page is going to help eradicate this entire class of cross-domain vulnerabilities. I'm not promising you that there won't be something that someone calls a cross-domain vulnerability in the future, but I can tell you that the architecture has changed such that these two classes of cross-domain vulnerabilities go away. And to that point, people really overuse cross-domain in ways that aren't really valid if you're in browser security. So I can stand by that statement.
So presumably some bunch of sites are going to break with this change?
The question was, will some sites break with this change? And there's certainly that possibility, but we expect that this is actually, we expect that legitimate sites probably aren't using this. An interesting scenario is, two sites that are really owned by the same owner that are either, different subdomains or they're different subdomains, or it's just two different top-level domains, and it always just kind of worked because they were using this issue. But that's the extent to which I would expect to see an impact for legitimate sites from those architectural changes.
So even with the redirection, it maintains the page render, maintains the original domain, when you switch between, what happens?
In the new, so the question was, after the redirect, will the page rendering engine maintain the original or subsequent domain name? And what we're saying is that, and this is actually, the page rendering engine will be aware of its new domain name, but more importantly, the access control check will not allow anything to come back after a redirect that doesn't say, I know a redirect happened. I know a redirect happened, and I want to go to the new page, right? I know a redirect happened. I know where I'm going. This is the domain I'm trying to get to. Does that make sense? OK. OK, so ActiveX controls. When we looked at the data flow diagram, I said, hey, ActiveX or any extensibility signs up for all the same security threats that we sign up for when we build the page rendering engine. So examples are buffer overruns, script, page access, check failures, effectively cross-domain vulnerabilities. And there's a large number of ActiveX controls. Right now on XPSP2, users don't have any control over the ActiveX controls that are pre-installed on their system. Once the control's been used, they could go to Manage Add-ons and disable it. But if the control has never been used, they cannot disable it. So there's no, out of the gate, if I find a vulnerable ActiveX control and I send you some HTML that tries to take advantage of that, I can silently load that control in the page and potentially realize the exploit. So there's a threat here, and the threat is really about attack surface. The threat is about the fact that there are a large number of controls that are installed by Windows and by Office and by ISVs who drop files on the system. And again, the user never said, I want to use Macromedia Flash. I'm sorry, they do say, I want to use Macromedia Flash. They never say, I want to use the Office 2003 web component, Excel, spreadsheet, aggregator, and web page. They never signed up for that. They didn't know that happened to them. So the change that we're going to make is that an ActiveX control, and this is a dramatic change, that an ActiveX control installed on your machine, used for the first time, will have the same user experience as an ActiveX control that you downloaded and used from the web. Dramatic, breakthrough change. But what this really means is that by default, your attack surface goes from all of the controls that you've installed down to a very small number. So by default, we'll leave the Windows Update control available because we know folks need to update their systems, and we can't trust that they'll get through this experience if there's a critical vulnerability. We need them to get updated. And that's actually it. That's in the current plan of record. And this is a beta 2 feature. This is not in beta 1. But in the current plan of record, every control that's not a part of the IE platform or Windows Update would be disabled by default.
What about Office Update?
Office Update would be installed by Office, and that would be disabled by default because it's, again, not a part of the core IE platform, not a part of Windows Update. There's a great question here, which is, Rob, how do you decide, or how do you advise ISVs about configuring this on behalf of their users? And I'm going to say, we haven't worked through all of the guidance for an ISV. So, for example, I don't want Office enabling every control that they drop on the system. But the Office Update control is a control that actually, you know what, it's probably better if that thing's running. Yep. So articulating the principle with ISVs and with non-Windows folks is really important, and I don't think we've gotten to that yet, which is part of the reason it's not in beta 1. Actually, that's a lot of the reason. This isn't rocket science technology here. This is the same prompt we've had before, but getting to the point where we have an easy way for an ISV to get something enabled that needs to be enabled, and understanding what their responsibilities are. That's actually been more challenging.
What about auditing the controls after the fact?
Auditing the controls after the fact. So I think your question is, should we enable ActiveX controls or do a security audit, rather, of ActiveX controls that are installed and try and find the unsafe ones? Is that the question?
My question is, where do I go if I decide I want to...
Got it. Okay. So the question is, as a user, how do I disable an ActiveX control after I've installed it or given it permission to run here?
How do I find out what I have clicked on? I click.
Got it.
Yeah.
Great question. So this is actually built on the Manage Add-ons experience from XP SP2.
Yeah.
So all I have to do is go to that same Manage Add-ons control panel, and it'll say, the following controls are enabled versus disabled actively in your system.
You might have something that directs you there from even that box.
That's a good idea, to actually flag this this prompt with an option to go see what the settings are right now. And that's a good one. It might be something we kind of stuff under the more settings, the more options, expando. Yeah, I like that idea. The other things I'd like to do, there are other things I'd like to do here that I can't promise we'll do, but I'd like to see us not give the user a chance to just run it once.
Yeah.
That's something I'd like to have us be able to do.
For X amount of time.
Yeah. Now, again, that's something where my guess is that our poor parents who really never want to see this dialogue in the first place really, hopefully they actually only see it once.
The way the warning is worded, it sounds as though it's added on a per computer basis, not on a per user basis. Is that right?
Actually, it is a per user basis here, and the control was added to your system, but it's not enabled for your user profile yet. So that's good feedback that we need to incorporate in the user experience here.
The user experience is a lot better. I remember an old message, I think it was 96 or something like, this ActiveX control might be unsafe to work with other parts of the page. Do you want to allow this interaction? Do you remember a message?
Yes, actually, that's still...
I wrote it. Wait.
Yeah. No,
it made it sound like it was only going to mess with that page, I always thought that was one of the oddest messages I've ever read in my life.
You're right, and what you saw there was what I believe was a control. There's a setting for only use ActiveX controls that are safe for scripting, and I think I've got it handy here in this slide. Initialize and script ActiveX controls not marked safe for scripting. So for whatever page you were at, it was in a zone where you had this setting set to, I believe enable and prompt they actually both throw that prompt. So what you did is you had it set like this, and then that lets you create objects that aren't safe. A great example is the Windows script host, the FSO, the file system object. That's a fun one. So by calling the file system object and by setting that security setting to an unsafe level, hopefully in your trusted site zone or something, then you actually stumbled on that prompt. But that's actually the location you would have most likely seen it would have been in a local HTML web page in the My Computer zone. So that's really the only place where I think that this is set to prompt. I believe it's disabled everywhere else. Does that make sense?
Yeah, I think it makes sense.
Okay.
Still don't like the message, but that's the best explanation I've heard. So,
well, thank you.
Well done.
Okay, so I think. Okay, hold on. We are now here. So buffer overrun mitigations. The buffer overrun work that we do on the IE team is actually the same as the work that's done around the rest of Microsoft. And I don't know how much you've already heard from Steve and David, but for those who aren't so familiar with buffer overruns, the idea is I take a big string or a big piece of data and I copy it into some memory that's just not ready to handle it, and the things that hang out over the edge become the new instructions for my computer to go damage the system. So the way that we handle that is through better programming practices and better kind of building and compiling practices. So in IE, we configure the build process to make sure that we're using safe APIs that aren't as susceptible to these mistakes. We have code review tools that actually simulate attempts to overrun the memory buffers. And we have fuzz testing that actually, with the real code after it's been compiled, jams all sorts of just really unfortunate data into those APIs looking for a buffer overrun. So this is something that is a part of the SDL and very, very core to something that not just we do on the IE team, but we do everywhere. So I can move on here. There's nothing IE specific about this.
Are you telling us that you compile with the GS?
Absolutely. We absolutely compile with the GS flag. The GS flag is a compiler option that that sets effectively like little data tags around memory to try to detect when a buffer overrun is happening and prevent it from happening.
You haven't done anything extra to prevent stack overflow?
Jeff might be the best person to answer that question about the things that we've done in the Windows build process for that.
The toolset team, the VC team, has constantly improved things, added cookies in various places, and exception handlers, stack walks, and stuff like that. And I know IE tries to, like most of our software, picks up latest sets of the tool sets.
We actually mandate compiler version.
Yeah, so we mandate latest toolset versions. We put a lot of work into the toolset version. Then we also mandate latest versions of the static analysis tools, the prefix and prepass. And all teams, including IE, aggressively pick up bits of that.
One of the things that we have been doing, and this is to give you guys the real deep insight into what's going on, we've been grooming the code base to be more and more compatible with these tools so that we have a higher hit rate with it. Yeah. So there's annotations you can add to the code base that allow it to return higher confidence results, and then as results come from those tools, we can go and address them with more certainty.
If someone told you about them, he's talking about SAL annotations, which has been, I think, Steve, you can attest that. I think we found that when we go back and SAL annotate stuff, that it really does find a high percentage of the issues that we had missed before.
Is that going to find heap overflow problems?
Yeah.
In format string?
Yeah. I believe so, yeah.
So, I mean, another question is, just in terms of rewriting core string processing, get rid of zero terminators and carry the bounds or use the right classes. Yep. What has that been done systematically? I mean, I know that's.
I mean, this is a Windows-wide effort. So, what you hear from Steve and Jeff will be valid for IE, and specifically, URLs we've gone after with a vengeance, not just because we're worried about buffer overruns, but because we need to handle them with even more care.
Yeah.
So, the scenario that I think that leaves in question for you might be HTML parser buffer overruns. Like, we get the object tag with the random string on it. What do we do with that? And that's where the remainder of these tools and processes and practices come in.
I'm not sure if your question was also, why do we still use stir copy in our code? And if that was the question, the answer is we don't anymore.
Yes, thank you.
No, I mean, I can imagine putting some more redundancy in. So that is, define a new string class with the size carried with it.
Secure CRT. Oh, using just for a basic string class?
Yeah.
I think mostly what we've done so far is replace the APIs that we use and manipulate with strings to always require the length to be passed with it, rather than carrying the length.
We use the static analysis tools to detect the unsegmented APIs.
And then the annotation requires that you annotate which parameter was the length of the string so that the static analysis tools can better make sure that, yes, if the length of that string was passed, you really were passing that value to the stir and copy or to the new secure CRT APIs.
So,
Rob,
sure.
But it's still the case, though, that if there's successful overrun in IE, it will take over the whole of IE, right?
The question was, if there's a successful overrun, will it take over all of IE? And the answer is well, yes, you take over IE. Now then the question is what does that get you?
Yeah. The question behind that is, have you thought about now that you have a nice architectural diagram of moving some of the pieces into separate processes?
Yeah, that's a great question. So since a buffer overrun could take over all of IE today, what are we doing to separate different pieces out so that a buffer overrun couldn't take over those pieces? I mean, Jim Alchin is really good, and he told me he was teeing me up to talk about low rates IE,
Yeah.
but I couldn't have asked for any better introduction for low rates IE. Does anybody here know what low rates IE is? Has anybody talked? So the scenario you just described is a buffer overrun takes over IE and something bad happens. I'm going to get to that in a second. We know that good things can happen too with IE. I can be browsing the web and stashing some files in the temporary internet files to keep a copy for later. I could be downloading a picture from the web. I could go change my home page, and that's going to go right to my user profile. And I could also need to go and get my new drivers from Dell.com, or I might want to run Windows Update. Installing an ActiveX control is also a per-machine operation that frequently happens as launched from Internet Explorer. So buffer overrun happens, and buffer overrun can use the privileges of the user to write to the local machine directories and the program files, for example. So that's one way that malware might get installed. An ActiveX control falls over and has a logic error. Didn't parse an URL correctly. And then maybe that ActiveX control running inside of the IE process leads to malware being installed in the user startup folder. So those are two ways that IE running at the user's level of privilege can result in a vulnerability. So this is an interesting case where we are changing the architecture, and it is a mitigation. It is not an architecture that completely eliminates vulnerabilities. This new architecture runs IE with lower writes. We call it LORI, and we use an integrity control barrier. This is a new feature that's part of Windows Vista. Integrity control, similar to the write-restricted token, that prevents me from writing to files I shouldn't be able to write to, like in, let's say I'm a low rights I'm a regular restricted user, and I can't go right to the program files folder, right? It's the same idea, except integrity control is able to mark specific programs so that they're kind of more holistically controlled. They're not able to access APIs. They're not able to access files, et cetera, et cetera. They can see, but they can't write. So low rights IE, for browsing the web, what the place it needs to write in the file system is simply to just cache things in the temporary internet files. But hey, what about saving a picture or installing an ActiveX control? This is where we've separated out pieces of the architecture. We've introduced a broker process, and the broker process is going to run at actually at the medium. There are two of them, so they're broker processes, but I've simplified it for the purpose of the diagram. One for the user rights access and one for the admin rights access. And both of these have a very constrained set of operations that they're able to do, and they do a lot of data validation that, hey, is this a picture? Is it safe to save it here? And then prompt the user and say, user, do you want to save this picture? So imagine there's a vulnerability that takes over low rights IE. The vulnerability takes over low rights IE. It could send a request to the broker to save something, but it can't actually save it without the user confirming and making the decision to save it. It can't actually install an ActiveX control without the user deciding that they want to install that ActiveX control. So what this does is it creates kind of this last line of defense. If all these other protections fail, we have an architecture now that is it's protected against effectively elevation of privilege. So
to play devil's advocate, though,
sure.
If he has taken over the stuff on the left, he probably has all the user passwords already.
So the question is if low rights IE is able to take over.
If someone has taken over.
If a buffer overrun has taken over low rights IE, can't I just use the things I've learned in order to take over the rest of the machine? And that's a good.
Or take a Fidelity account.
Yeah, exactly. So that's right. I can potentially go and use that as a cross-domain vulnerability. And in that case, though, a cross-domain vulnerability isn't installed. I might be able to get to fidelity.com from badguys.com, but what I can't do is put a bot on your machine that forces you to badguys.com every day, or that continues to pump email for the next 3 months out to everybody around your neighborhood, trying to get them to install the bot as well. Does that make sense? So the vulnerability has been contained, and this is where Jim was talking about how low-rates IE doesn't necessarily protect against the privacy of your data, because your information could still be disclosed in the event of a vulnerability, right? But the vulnerability can't be used to elevate privilege against you automatically. Okay, so I've actually got a demo of this. Oh wait, hold on. One more thing to show here. Okay, so I'm the Flash ActiveX control, or I'm the Google toolbar, and I've been happily running inside of IE for the last 4 or 5 years, and I write my settings into the user right access section of the registry, because that's what Microsoft told me to do. Everything worked. They come along with this low-rates IE thing. Nothing works. Well, to prevent that from happening, what we've done is we've added a compat redirector. And any time that the Google toolbar tries to write the list of sites that you've searched for that it wants to remember, we'll detect that it's about to write something that's going to fail, and we'll redirect that down to a temporary internet files rights level, so that it can have its little scratch pad of settings that it needs to remember, but not actually accidentally elevate privilege. So that's an important thing that we're doing, because we can't put the security mitigation out there and protect people, but then have them not able to use the browser and not able to use the extensions that are important with the browser. So that's an important part of the solution. Now if my demo machine's been ignored so long that it might just decide that it doesn't want to cooperate anymore. Okay, so the machine is alive, I think. Okay. So the first thing I'm going to show you is an ActiveX. This is XPSP2 running in a virtual machine, and it's looking at a page, and the page is hosting a control that we wrote on the IE team to demonstrate a mistake that an ActiveX developer could make, right? So if I write a bad ActiveX control, it might be able to drop a file into the startup folder. So you can see I've got the startup folder configured handily as my drop destination. I've got a wonderful little command for that batch file. And is the startup folder? Yeah, startup folder is visible. This is the startup folder over here. Anything that goes in this folder is going to run every time I launch Windows for the rest of my life until I figure out how to delete it. So that ActiveX control did what it was supposed to do, because it's for the purposes of demonstration, and dropped an evil file in there. I'm going to leave it in there for the next person who runs this demo so that they can deal with what they did to me. Just kidding. Okay, so let's see what happens when we do the same thing in IE for Windows Vista. Now, this time, when we're looking at IE, this IE has been created without the permissions to write anywhere other than the temporary internet files. So the most dramatic thing I'm going to show you in the demo today is create file failed. Great. OK. So folder's empty. User's safe. OK, so this integrity control barrier that we have is working. We know it's working because it's the same ActiveX control. It's the same HTML. It's the same nasty command. It's great that that's working, but how is it possible that we're going to be able to change the settings? So here I'll go to, I'm going to open up the Internet Options dialog. Now, the moment I click the Internet Options dialog, low-rates IE sent a request to the broker and said, the user's about to do something I don't have permission to do. Broker, please take it from here. So this Internet Options dialog is actually running in a separate broker process, and that broker process is running with enough privileges to modify things about the system. So here I could go ahead and change the home page, and that's something that's going to be written to the registry. And I should have shown you the home page before. Well, the home page was the evil page, because that's how the demo works. And here now when I go back to my home page in IE, what you can see, again, not super dramatic here, but the right that was written to the registry by the broker has been respected by low rights IE. So I'm able to consume the things that the broker does for me, but I'm not able to do them myself at this point. And another thing that's important is the user experience so far has been transparent. There's nothing that the users had to see, no approval they've had to grant, no time they've had to type in their password or offer up their firstborn child to install a file or save something from the internet. The broker is...
Because the broker is more privileged than the...
That's right.
The broker is your classic, basic, trusted process.
Right. So
just like in Viber or Bellevue.
Okay. So what's to stop some hostile piece of code from asking the broker to do something that hostile piece of code really shouldn't do, but the broker will be allowed to do?
Great question.
Trusted.
So the question was, what's to stop a hostile piece of code like a buffer overrun gone wild inside of low rights IE or an ActiveX control gone wild inside of IE from asking the broker, which is a trusted process, from doing something dangerous that it shouldn't be doing. And there's nothing to stop it from asking. There is something to stop the broker from saying yes. And the thing that stops the broker from saying yes is parameter validation on the request, right? Because we've created brokers for a limited set of scenarios to do a certain set of things. And then also the fact that the user gets to consent if they want to actually do the thing or not.
You mean every time the broker is asked to do something, it pops up a dialog box?
Well, the broker doesn't get asked to do things except in scenarios where it would need to elevate to medium, right? So it's not like you're interacting with the broker frequently. You're only interacting with the broker for scenarios where it used to get a problem. But the point I'm trying to make is there's no net change to the experience in the default case.
And I understand that part of the picture, and I'm trying to understand whether there was a free lunch or you created a potential set of vulnerabilities.
There's no free lunch, so the question was, is there a free lunch because we've got a broker? And is the broker vulnerable because it's like a clone of the old IE code and just sitting up at a higher level?
No, is the system vulnerable because it's now possible to spoof the broker into exploiting its privilege on the behalf of some piece of hostile
The answer is definitely no. I think, Rob, you started to talk about like some of the things like file open broker or APIs and stuff like that. The APIs that the broker exposes to the limited rights process are things that would be safe even if it was being driven by an ActiveX control. So the broker exposes an API to show the user the IE's options dialog, not to go change the user's homepage, but to show the user the options dialog. So buffer overrun could allow an attacker to pop up the IE options dialog. Another example is the file save dialog. We don't expose to the broker the ability for the low rights process to save to the hard drive, but we have a way that the low rights process can say, the user's initiated a file save, display the file save, let the user choose the location, and save that data out to the disk. So a buffer overrun could lead to an ActiveX control, or a buffer overrun could let a malicious person pop up this file save dialog, but the user would still have to choose, I want to save something to this arbitrary location. Does that make sense?
Here's what I'm worried about. Okay. There's this broker, and its job, among other things, is to make all the existing reasonable content work in this setting. That is the compatibility problem. Okay.
That's not the broker. That's a virtualization engine that runs in context of the low rights guy. So like we virtualize.
That's invoking the broker.
No, the compatibility does not. Let me go back to the other window.
When you
hold on.
You gave this Google toolbar example.
That's the compat redirector, and the compat redirector does not interact with the broker at all.
So inside the low rights process, they virtualize the registry and program files.
Okay.
So that if you try to write to the program file.
So if there's a vulnerability there, you escalate from low to low.
Yeah. So if you try to write to program files, even though Google thinks it's writing to program files, it's really writing to a private copy.
It's really writing to...
A malicious person does, it's really relating to a private copy. Sometimes you got to get out. When you want to change your home page, you got to get out. So that's what the broker is there for.
Could the bad program or it's taken over this copy of IE, it puts up a window saying, I need to do something special. You know, your wonderful new security controls require me to put up the following window, so please click on the yes button. So when it does put up the dialog, you will say yes.
Yes, there's a potential for a social engineering attack here. We've had the user as a threat all along, and there's still a threat that the user makes the wrong decision about a prompt that's come from showing up as a result of the vulnerability. Now, our intent is to code the broker such that the spoofing options there are minimal, right? And we're still working through this. This is a beta 2 feature. It's also a really big bet, and it's going to take a lot of refinement before we're able to say with certainty that we've reached that level.
For me, off the top of my head, to understand exactly what it is the broker can do. Okay. You're changing a home page doesn't seem so serious, but I can't remember what all the other options are.
Sure. So, yeah, the broker can do the things that anything that isn't caching a web page, you should think of as being done by the broker. So, saving a web page, saving an image from the system, any of those things, you should. Anytime you interact with IE and you decide to make a change on your system, that's a scenario where you'd be looking at the same UI that you've always seen before. It's transparent to you, but that's now running in the broker process at a different privilege level. So really, what we're saying is the experience should be the same for the 90, maybe the 80% case, and we've removed all of the functionality from the browser that is necessary for legitimately elevating privilege, where a user legitimately needs to elevate privilege. And we've put that into a separate process that we think is safer from elevation of privilege.
But, yeah, and I think, Jeff and Rob, correct me if I'm wrong here, but the broker process will perform a finite set of actions that they can enumerate and nothing else. Some of them are relatively powerful in the context of the system, but at least it's finite, and and so they know what the inputs to the request to do those actions are, and they can validate those, as opposed to have the current case where the default has been, basically having IE run as you as admin, or even IE run as you as ordinary user, and then an escalation in IE, script getting arbitrary code to run or buffer overrun or what have you, means that it's sort of game over either at the local user level or at the admin level, depending on how you run.
So Chris, specific to your question, I'd love to be able to enumerate here. I can't. There's a spec that has all that information. What I'd like to do is to follow up with this audience with more documentation about IE afterwards, some reading materials. This slide deck is actually kind of the nucleus of a white paper that I've been bouncing off of Steve a little bit as I've been able to make progress on it, that explains the threats and the mitigations in more detail. I think specifically we should come back and talk about the things that the broker can do. I would expect that would probably be under NDA until I hear otherwise, but obviously that's information we want to share with this audience. Does that handle the question? Okay.
It seems like a great architecture for other apps. So
yeah.
Wondering how much thought you put into that in the design, or what's going down the pipe?
Okay, well, thanks. The question was, it seems like a good architecture for other apps, and we agree. We have been working with folks in the kind of cross-Microsoft security group, like like Steve is in to help other teams learn about this architecture and learn about the challenges we've had and go try to implement it themselves. And then I would expect that third parties would want to as well. We've already started blogging about it as we've taken it on. I'll be clear that this is not easy. This is something that has a lot of challenges in it, and it might be something that is a while before the next follower comes along. But we think there's a huge benefit to it.
I mean, the folks, who date back, to antiquity, of which there are at least two in the room, three of us in the room. I mean, this is an honest-to-God application of FIBA integrity, okay? And those are rare on the ground, so we're trying to work, we're trying to actually make it work for something useful.
Well, I guess I'm just asking why it's not a Windows service in some sense.
I mean, there are two things. There are two things, okay? The trusted process that allows you to manage settings. The broker process is unique to the application, and those are always unique to the application.
Okay,
the underlying mechanism, the MIC, the mandatory integrity control, is a core piece of local.
Okay, I get it.
Exactly, and that's actually why it's not in IE7 for
And I believe the virtualization is as well, right?
The virtualization is as well, but that's right now that's custom. But I don't know how custom it is, but there's some, there's some stuff we've been like, well, we want it to be right here and not there, and blah blah blah. So
I have to work that through the compat rules.
The general infrastructure for compat is definitely an operating system dependency. The other thing that I don't show here that makes this a little bit more challenging is that we actually have. There's a scenario where the user says, enough with this low rights IE thing, I'm going back to good old IE that writes anywhere. And we actually do have the fallback behavior for example, sites in the intranet zone. I can demonstrate that. But the thing I want to tell you is that there's also now a low rights temporary internet files and a kind of temporary internet files immediately above that at the medium rights level. So you could imagine where David's standing, is medium rights IE, and then medium rights IE never reads or writes cached files below this integrity level, so that low rights IE can't pollute a medium rights IE cache. So I'll really quickly demo how that works. I know actually the jokes I made about the intranet before and our parents, are true, but then the scenario is also that we need to have the ability to use corporate line of business applications inside of our intranets. Enterprises won't deploy this thing if it's going to break their line of business applications. But we know that the content that's on the intranet is generally more trusted than the content that's on the internet. And we trust it extra special more now because we've redone the whole URL parsing architecture. So I can't download the MSN toolbar. I have to do offline. It's a long story. But what I'm going to do is I'm going to navigate to a simulated line of business application. And this is a site that we forced to be in the intranet zone. And what you see is that it created a separate IE window. Low rights IE said, I'm going, the user wants to go to the intranet and sent that request up to the broker. The broker then parsed the URL and said, yes, lo and behold, this is the intranet. The user does want to go to the intranet. Then the broker created a medium rights IE special for the intranet that can never go back to the internet. And this version of IE, I can open up my documents folder here. Now, imagine I've got a line of business application and a cheesy pitch for people to come work on the IE team. I'm serious. I mean it. And here, this guy is able to write. It's using the same ActiveX control, this time for good instead of evil, able to write a document to the user profile. So you can see how we have the power to lock down IE, but the flexibility for enterprises and customers who can't live with that scenario. And the experience is seamless, modulo, going back and forth between windows for intranet and internet. If I type in an internet URL here, an internet URL here will actually go and navigate the low rights IE window again. It will not. An internet URL will not be able to navigate a medium rights IE. So. An URL in a Word document, the first thing that happens is when IE gets created, the broker looks at the URL in the Word document and says, intranet or intranet. And if it's intranet, it creates a low rights IE process. It loads it there, right? And if it's intranet, then it will create a medium rights IE process and load it there. But again, URL parsing could never be more important than now. It really, I mean, it's one of the most important things we're doing. So we actually walked through this already, and should wrap up here because I know there's people who have to catch flights. And so first of all, I want to say I'm really glad that I got to come back. Wasn't sure after last time if I was going to be invited back or not, but this has been a really awesome experience to be able to show you guys the work that we're doing. I've tried to show you how we're increasing security, but at the same time trying to not scare people out of upgrading to IE7 or to Windows Vista. Tried to show you that we're using threats and data to drive the investments we're making. And the shameless IE recruiting plug isn't necessarily to this audience, because I want you guys to keep doing the things that you're doing. But I know that you guys have a pool of talent. And the importance of you sending talent to us, if you have students who are brilliant, if you have colleagues who are interested in getting involved in the industry, Steve's probably going to slap me for making this statement, but the IE team is hiring. We're hiring big guns. We're hiring people who are hungry to come help. And it's the best job I've ever had in my life, and the best job I've ever had at Microsoft. So I'm serious about it. So how many jobs have I had in my life? Somebody asked me that question once.
Best over some set, right?
Yeah.
How big is that set?
Let me answer that question in a different way. Somebody asked me that once.
Much better than my prison guard.
I was told, it was really funny. I was asked that by somebody once in a meeting as a way to try to determine if, as a way to gauge my credibility. And it was really funny. This person actually reported to me. And I looked at them and I said, I have had one full-time job at Microsoft. I've had probably 4 roles in my time at Microsoft where IE security has been the single dominant factor. And I said, if you think I'm wrong, I'm happy to listen and I'm happy to take the feedback. So if the question is pointed at gauging my credibility, I want to let you know that I'm open to the feedback, and I'm open to listening to what you have to say about the things I presented today. But I think I'm pretty confident about the work that we've done, and I'm confident that this is going to stand up. Is that a fair answer?
I think that IE has always been one of the more innovative
groups within Microsoft in terms of, specifically in testing, which is what I'm most familiar with. And I wish you would have been able to address that, but there are time limits. And I'm impressed with what you're doing here. And my question is, this level of detail, who's next? I mean, is this going to go? Is Avalon reusing this code? Are they doing the same things you guys are doing? Because there's.
Well, that's a great question for Mr. Lipner. You need to get the Avalon guys done.
Avalon's a pretty key new technology.
Right.
So,
Avalon, Avalon is, as Jim said, Avalon's built on the managed code framework. So some of the things are not, they have some different, lower level solutions. They still run, they still do the same techniques in terms of, threat modeling, focus on attack surface, and so on. And they still run it on the operating system. So that means you know, that they have the access to the NIC and I can't think of the name of it, Lua, you know, limited user access as a way to provide a safer environment by default. And, you know, and those are things that will, you know, from the slide perspective, those are things that will be, you know, insisting that they do going forward use the platform.
So my impression of this has been very positive. What's your impression of how this team's doing compared to how some of the other major product teams are doing in terms of applying the SDL and paying attention to what's important?
Yeah, so the Greeks is boss, so you should
right. I mean, I
take that accordingly.
Right. I mean, you know,
I mean, if I've been fooled and this guy really sucks, I'd like to hear it from you.
No, I mean, these guys are serious, and there's been a sort of a significant turnaround in the last, you know, 2, 3, 4 years. You know, my immediate boss is the former IE test manager, so that's sort of a funny thing going back and forth, because IE was not our happiest product from a security perspective, you know, 3, 4 years ago. But I mean, you know, that it's become a priority for them for some time. First thing they've had to do is just to get a handle on their vulnerability rate, you know, the sort of external report stop the bleeding issue. And now, you know, and then SP2 was a start at making major investment, and this is an even more major investment in terms of really getting things turned around. And I think, you know, I mean, as far as I can tell, they're serious.
Along with George being in security, you know, you asked about the jobs I've had. Fred?
It was, I think Fred actually was asking because you said it was the best job he'd ever had.
Because
Selling it to the students.
He was just giving you a hard time.
I think it was just.
Okay. So it's a great job because we help protect people. But part of the credibility of the team that we've built lately is about bringing back folks who worked on the original product and who have the insight to understand the types of decisions and why they were made, so that we can go and remake those decisions and redo them. So, for example, the development manager and the dev architects, each of them probably have no less than 5 or 6 years experience working on IE. Yeah. Of my 7 years, I've spent 4.5 or 5 on IE, and that's. We had an old team. We're back. We're serious. Actually, Dave, even though he's not on the IE team, is probably our best loved kind of expat over in the security business unit. So there's a strong history of the alumni coming back. We started coming back in droves, and you know, the team's been exploding. So to the students, what's that?
How big is the IE team now?
The IE team right now is 130 dev, test, and
Smallest
PM.
it was a few years ago?
What's that?
What was the smallest it was?
The smallest it was a few years ago was probably 50. I think that's the smallest it was. There was a point, like I said, where I had left IE, was working on Windows Shell stuff, and around Server 2003 was when I came back in the fall of that year, and we started bringing the band back together. So knocking on people's offices, saying, "Hey, you know, I know you don't work on this anymore, but I want you to come. I want you to come join us." So to answer the question for your students, there's no place where, you know, so few people can protect so many people, specific to security. Like the impact of the work that Dave and the rest of our security research team does, you know, absolutely fundamentally changes how people's security is on the internet. The work that we get to do as a program manager with partners external, working with you guys, getting feedback, means that we get to help make decisions that have the same kind of huge change. And the developers are all, you know, they're just awesome. They love what they do. They love the customers, and they love the mission.
So I don't want to cut this off, but I am now going to cut it off. We're 15 minutes into the break, and
if you guys have any questions afterwards, please, you know,
sure.
grab them.
Yep.
Okay, thank you very much.
You're welcome.